Yes, welcome to the session, Cybersecurity and in the Age of Quantum. And we have the pleasure, with three, to give you an insight and inlight what this means. I have the pleasure here to welcome Dorit and Jan, the top specialists in their field. But what we are talking about, allow me to give you some quick ideas. Well, we are surrounded by technology. We love technology. We need technology. How to make otherwise green transition, climate change, how to master all these big challenges we have. The answer is technology. Only technology can rule this. The question, however, is security. Well, we need to trust the technology. Otherwise, we could have problems. And the question is, how can we trust? What is the threat landscape? And then afterwards, we come to quantum computing, where we say, okay, quantum computing can solve, it's not a silver bullet, but they can solve everything, or not precisely everything, but a lot of points to say how to solve problems, like optimization problems, that we never solved before. And this will be the topic of our panel, to give you an insight what in area we are, what are the threat landscape, and of course, what have quantum computers to do with this? And so allow me to introduce you first the panelists, and I have here Dorit. Dorit is Vice President and Chief Product Officer at Checkpoint Software, and one of the world's leading women in cyber. And with Checkpoint more than 25 years, and everything what Checkpoint is doing, it's under her control. So I liked especially when we introduced ourselves, she said, okay, email and cloud security, one the next of Checkpoint rockets. I would argue, being from the network security, apologize, that network security is the rocket.
It's still the rocket, yes.
Okay. So, Dorit, what are the great challenges from cybersecurity from your side? What do you see the big threat landscape?
Yes, so I think that the biggest threat landscape is whether people take it seriously. Now, after we put this aside, we may continue and talk about this. Then the main thing is that security is part of the environment. It reflects, if you think about how a hacker thinks, then it's an asymmetric problem. They need to find one problem. You need to defend all the problems. So if we just look at the last few years, let's look at new things. People move to work from everywhere at any time. People doing a dramatic transformation to digital, cloud, using SaaS services, with that IoT and automation, AI, etc. So, and then comes a lot of the security is delivered by developers, so either automation of all security manual tasks or all the infrastructure as code. That brings supply chain. And then we take new technologies like 5G, and what are the challenges that 5G would bring, and then we have quantum. So in every one of these, something gets added, and a whole new space is opened for the attacker. So we could drill down to any of them.
Are we not? We are actually very static. We have static firewalls, intrusion detection, intrusion prevention. Should we not more make the attack surface dynamic, make dynamics, so the attacker would not have, as you said, the asymmetry just to go inside our systems?
Yeah, so I think we often, as industry, settle for the regulation. There was a question before about regulation as well. So I think regulation can help it be not zero, so somebody has to protect themselves. But regulation doesn't bring the right level of security. I'll tell you a short story about our masks from the plane. We have very good masks from a company that generate medical equipment, and we use them for flying. But the regulation by Lufthansa, and I assume German regulation, dictates certain types of masks. So I thought when I'll go over the plane with my good mask, they will allow me in, but no, in the entrance, they wanted me to replace my great mask with a very simple, you know, the white-blue kind of $1 mask that, in my opinion, doesn't protect much, sorry, but it's regulated, approved, certified. So great, I took off my great mask, I replaced it with this white blue mask, and I was all safe. So,
but not secure. Not secure.
So I think that my answer is that we do have to evolve, but that one of the problems is that people have a lot of things on their mind, and so they settle for the easy solution, and sometimes for the easy solution doesn't give the right answer for the whole.
Okay, thank you. Jan, you are CEO and co-founder of IQM, and you're building actually next generation quantum computers. And I also read a quantum computer, the first quantum computer for Germany. And you are actually has a PhD from Technical University here in Munich, and yes, building IQM in the Leibniz Supercomputing Center. Tell us about this. What is your mission?
Yeah, so thanks, and great to be here again at DLD. So quantum computing, I see it very much as an accelerating technology for computing. So similar, for example, if you look at AI applications, you really want to get the performance out, you run them on graphical processing unit, on GPU clusters. So you can see it in a similar way, that there are certain problems you want to solve, and if you would just use a supercomputer, it would take forever, let's say hundreds of years. So you need acceleration, and the quantum computers can provide this acceleration. So it's really the field of high-performance computing, and it is deep tech, and deep tech means there is still some time to develop the technology. And of course, for a startup like us, the challenge is, okay, how do we survive the long way until the end? And usually you need some kind of revenue. Look, for example, at SpaceX, what they did in the early days, they sold a lot through NASA contracts, made revenue, and this helped them grow. So this is the kind of story that we are trying to build, and here in Munich, there is a great supercomputing center, the LAZ, Scientific Computing Center. So they see themselves also as innovators for new compute technologies. And basically, we there adopted a little bit the SpaceX model, that they are now buying from us a machine, which helps us, of course, with our startup story, but it helps also building the ecosystem here locally. So another example there is, for example, if you look at Cambridge and AI, there is a lot of hardware compute power in Cambridge, and this then leads to the fact that many software companies are actually coming there. And this is kind of the ecosystem that we are trying to build also with such lighthouse projects like the quantum computer at LAZ.
But how would you say it? I would argue that in quantum computing we are still in the kindergarten age. Are we there, or are we in the
No, I think that's fair to say, but of course the kindergarten, we are already quite old in the kindergarten age, so I think the first
like
ideas,
5 years.
the first ideas came from Richard Feynman in the 80s already, so it's not a new concept, but what is happening now is that the use cases are getting, let's say, quite attractive, and the technology is so that we say in reasonable time scales we can be there. And maybe also here trying to connect a little bit to the topic of cybersecurity. So in the 90s already, there was a Professor Peter Shaw, and he discovered that you can factorize large numbers much faster with a quantum computer than with a classical computer, and this is kind of a threat. And it's not a big, or it's not a fundamental problem, and you can see also how these, let's say, very far technologies are still driving innovation than in other places. So I think in 2016, the National Institute for Standard and Technology, NIST, in the US, announced that they will now create a new standard, a security standard, which is post-quantum, and people should adapt to this. So you see how one technology, which is not even ready yet, is already affecting other very important technologies like cybersecurity, for example.
So I'm happy to talk about this for a second. I think that quantum computing brings a device that is likely to solve differently some algorithms that we grew, like knowing how to solve them or how not to solve them, etc. So it creates some uncertainty. But I think sometimes we mislead ourselves by looking at one problem. Actually, quantum computing could solve many different algorithms in different ways. And here comes a sentence of a physics a Nobel Award winner that says that it's very hard to predict, especially the future. So we don't really know what quantum computer algorithms would be affected. And for example, in the same way it may affect asymmetric, like a computational of discrete numbers, then it could also affect mining of bitcoins. So maybe with the presence of quantum computers, mining of bitcoins would be faster. Now, mining of bitcoins, if it's faster, it changes the whole economical model of bitcoins. So when you are a hacker and you think about security, one of the things is that it's not always the kind of the front door. There is a front door here, and let's look at the front door, and that's the threat. It's not always the front door. In the same way, I want to say, so people are, okay, what we would do, encryption, etc. But as a professional in cyber, very rarely people attack the encryption system. Mm-hmm. Most of the time, you attack the entry, the web, the support, the backend. I know that we've demonstrated few research documents on NFT and wallets, and all the wallets and NFTs we use to steal people, to demonstrate how to steal people money, none of them had to do with the cryptographical algorithm of any of these. Mm-hmm. They are all kind of a system entry point. So whether we would be able to evolve to a new encryption and strengthen the system may not be the biggest hole that is in front of us in cyber.
I think we are all agreed that actually we need resilient systems. We cannot have 100% security. We need resilient system. And each technology, like AI, is a double-edged sword. You can use AI for attacks. You can use AI for defend. And I think the same technology, we need to see how to defend these threats. How would you say, what are the biggest threat landscape currently?
So I think that the main issue is that people are giving up on preventing attacks. So they say, okay, we will get all these notifications and we will remediate. Now, we simply don't remediate at the pace of the attack. When an attacker has a weapon, they would target to use the weapon as fast as they can. Weapon meaning a cyber weapon, obviously. So they would target to use the weapon as fast as they can and have the best monetization out of this. So if you are kind of slow and waiting for this in response, you may not respond fast enough. Plus, the whole hygiene of the system is not there. If you use prevention, you have a much more clean environment where you'd see more things visible if they are bad or even suspiciously bad. Mm-hmm. So by giving up the enforcement kind of opportunity, you are surrendering to many problems. And I think that people find it hard to implement prevention systems, so they go for detection, and that's a big problem. But it's a problem. Already. Yeah, so this is a problem in network security and in cloud security and in mobile security and in any one of these vectors. So it's not per vector, but the problem is that people are not putting the guards in place necessarily. They think that they could respond in retrospect.
That's difficult. I agree. Jan, we heard yesterday that, for example, quantum computing is the promise for combating climate change, the qubits for the climate change. How would you say for cybersecurity? Is there also something, quantum computing for cybersecurity?
Well, of course, you can think about algorithms. So, for example, what quantum already at the moment are very good at is creating randomness. So you might think, okay, creating randomness is not a, let's say, useful case, but actually you can use it also then for encryption purposes. So there are some algorithms also that you might use for this purpose. But I think for me, it's really this kind of driving change and innovation and thinking about kind of long time scales and what does it impact. And it's also about how then you actually secure your findings, the results. So one application, for example, is drug discovery. And if you have, let's say, a breakthrough there, then you have also to think, okay, how do I keep this information? First of all, can I trust the result? But then if I have the result, what do I do with this? And I think this is something where we will see also change, and I think also some strategic decisions on which people might own, for example, the hardware where such computations are being executed on. So I think it's more than just the kind of security aspect of maybe the calculation or communication, but it's also everything behind, like cloud, and how do we then work with very sensitive data over the cloud, for example.
So I could add on this, so specifically because it's good in kind of computational optimizations, then there are computational optimization problems also in cyber. You could search behavioral, like it's kind of an annealing algorithm that you search the kind of the top places. So you could search bad behavior, exceptional thing that shouldn't happen in a norm, and maybe the algorithm there will be more cost effective, but there could be other technologies, other types of computers that would also make, or other progresses in technologies that could accelerate this. This is where comes the future of when we will have the better algorithms, we could say what are the best usages and how much more cost effective they are for us. But there are problems in cyber defense even, that this could help solve. It just, these problems are being solved now. Nobody is not doing behavioral enforcement just because we don't have quantum computers. So I heard that in the panel yesterday about quantum and climate changes, that somebody said that chemistry research should stop until there are quantum computers, because this would be the only thing that allows to simulate chemical behavior and therefore would solve the industry. So we are doing security today. So we are doing behavioral and we are doing many things. There is nothing that sits down and wait for quantum. But there is an opportunity that somebody would bring a much better price performance, amazingly different even algorithm than we think today. Not just some Shor prime would be born today and would invent a great algorithm based on quantum computing that would change our life in doing X, and that could impact cybersecurity as well.
Okay, that's perfect. So because we have a lot of technology around us, and it is developing extremely fast. And the question is, of course, how we can use the technology for the good or bad. So since we need a strategical view, what would you say, let's say in 1-2 words, what do we have to do from the side of quantum computing, from the security perspective? What are the priorities we have to address? Maybe Jan?
I think it's important.
Don't take just money. We need more explanation.
Yeah, I wasn't going to say money. Of course, money is important, and you can do a lot with it. No, I think we need to align roadmaps of the different, let's say, groups. For example, if I think about cybersecurity, I think it would be good to align, let's say, quantum computing roadmaps with cybersecurity roadmaps to see actually when do we have to meet, or should we already talk now, and then have communication channels between different user groups. I think this is very important because quantum comes, let's say, from the physics world a lot, from the labs at the universities, and now we are exploring, there's more out there than just university labs for physics. So I think we need to be talking about these topics much more.
Okay, Dorit?
So I think that the biggest problems in cybersecurity are not in the space of collaborating with certain technologies, but in the kind of strategy of companies. So when I ask, is this a strategic part of your thinking, I would hope that we are there already with most companies. I'm not that sure that we are already there. So the first place is kind of to decide that this is a strategic board level discussion and very important ingredients, because we see the attacks. I didn't come here to kind of tell you all kind of horror stories on attacks. Everybody reads them in the news, and so it is a strategic problem. Then after defining that it's a strategic problem, then you have to define your policy, your risk appetite, and to define enforcement accordingly. Yes, enforcement, prevent attacks on the most important assets. And then you do remediation and tabletop programs to kind of how you secure yourself, or how you remediate, how you respond to things. These are all kind of after setting a policy and enforcing it.
Yes, and maybe the final word from my side. Since I have the pleasure to coordinate a big EU project, Concordia, with 56 partners building the cybersecurity community, I can add to all these great discussions cooperation and building trust in terms of building ecosystems where research, industry, startups can work together and develop together. Because actually we are faster.
Yeah, there was a comment from somebody who I spoke in the break about the lack of very clear best practices. So even if not regulation, let's assume somebody do want to adopt prevention and security, how to do it and how to do it simple in collaboration with industry to something that would be acceptable.
Yeah, we talked, of course, not to, for example, cyber supply chain attacks and what this everything means. So the threat landscape is large. It should not be static. It should be more dynamic, so that we cross over the not to asymmetry of the attackers to the defender, but make it to the attackers difficult to attack the systems. So I would say thank you very much for this really insight panel. Thank you, Dorit. Thank you, Jan. And thank, of course, the audience.